Welcome back. Now let's look at indeterminate differences. Sometimes we encounter functions fx and gx such that limit x approaching a of fx is infinity and limit x approaching a of gx is also infinity. So how do you handle differences? Fx minus gx, limit x approaching a, is indeterminate of the form infinity minus infinity. So somehow we need to convert this difference to indeterminate form of the type 0 over 0 or infinity over infinity. Let's see what that means. Say limit x approaching infinity of x cubed minus natural log x. Well, you know this is going to infinity. You also know this is going to infinity as x approaches infinity. So you have indeterminate form of the type infinity minus infinity. Therefore, consider the original limit. Get factor x cube out. So what happens when I got the factor x cube out? I have a 1 in the first term. Second term, I have to divide by x cube. Okay, check for yourself. So once I do that, I need to figure out what happens here. Well, we just saw this example. Where did we see? There. This limit was 0. Okay. So this limit is 0. That is 1. So this factor has limit 1, whereas you still have x cube. So that takes me to infinity. So that's it. This limit is actually infinity. What does that mean? The infinity on the first term is approached faster than the infinity here. All right. Now, indeterminate powers. There are different types of indeterminate powers. In other words, look at these functions. Fx power gx. Now, if you have 0 or power 0, so that is this function approaches 0, this function also approaches 0. So that would be 0 power 0. You are approaching 0 power 0. It's not clear which one is faster. Regardless, that is indeterminate. On the other hand, approaching 1 here and approaching infinity there. 1 to any power is 1, but 1.001 to the power 1 million is a large number. Okay. So 1 to the infinity, the limit is indeterminate. Likewise, infinity power 0, that limit is indeterminate. So there are 3 types. 0 power 0, 1 power infinity, infinity power 0. Okay. So, by the way, 0 power infinity, that limit is actually 0 because you are getting smaller and smaller and smaller, and higher powers you take, they get even smaller. So that's why you don't have 0 power infinity. That limit is 0. It is not indeterminate. These 3 are indeterminate. There are various ways of approaching this. Take this, your original function, natural log. Okay, that's a standard way. So that comes down. Now you have a product case. If you have a product case, you know one of these, 0 times whatever, infinity times whatever. So something like that you can play with. So that's the approach. When you have power functions, take natural log. Another approach is to rewrite this function as e to the natural log. Okay, it is essentially the same argument. Okay, so let's look at an example. You will see better. X approaches 0 from the left hand side. 1 minus sine x. So 1 minus sine x. This quantity approaches 1. Whereas cotan x, cotan is cosine over sine. That approaches negative infinity. You see, or infinity, doesn't matter. 0, 1 power infinity, that's indeterminate. So When x is less than 0, you have 1 minus sine x greater than 0. Therefore, that power makes sense, okay? You don't take power of a negative number. Those are difficult to work with. You need to go to complex world. Anyhow, x approaches 0 from the left of sine x is 0. So 1 minus sine x limit x approaches 0 from the left is 1. When I take power, it is indeterminate of the form 1 to the power infinity. So set y equals 1 minus sine x power cotan x. Take natural log of y. So that comes down natural log of 1 minus sine x. Now, when you take x approaches 0 from the left, that's the limit, right? Of cotan x times natural log 1 minus sine x. If you look at its form, it is indeterminate of the form infinity times 0. So this can be converted. You divide by the reciprocal. Rewrite it with a denominator. Okay, now this is finally indeterminate of the form 0 by 0. So you are ready to take derivative. Derivative of the top, 1 minus sine x, and don't forget chain rule. Derivative of negative sine is negative cosine. Derivative of the bottom is secant squared. But what is secant squared? It is 1 over cosine squared. So cosine squared comes up. In addition to a cosine, you have cosine cube. Okay, so this expression is nothing but this expression. Now when x approaches 0, numerator is, that's negative 1 and that's positive 1, negative. So notice this was natural log of y. X approaching 0 from the left of natural log of y is negative 1. So what's the question? The question was for y, not with the natural log. So how do I address it? Take exponential, e to the power negative 1. That's your final limit. Here is another example. Find limit x approaching 0 from the right, x to the x. 0 power 0, that's indeterminate. So what do we do? Set y equals x power x, natural log y, x comes down, x natural log x. Now if I take limit x approaching 0 from the right, natural log x, this is limit x approaching 0 from the right, x natural log x. That's 0, that's negative infinity, indeterminate. So take that, put it down as a reciprocal. Now you have indeterminate of this form. You can take derivative of the top by L'Hopital's, derivative of the bottom. When you simplify this, you have negative x, limit is 0. So limit of natural log y is 0. So what is limit of y? E to the 0, which is 1. Okay. Now here we start problems from web work. So I'll come to these in our next video. Until then, bye.